Okay, in this video, what we're going to discuss is graphs of the trigonometric functions like sine, cosine, tangent, and eventually we'll get to the cosecant, the secant, and all that good stuff. So let's start off by taking a look at um, some graphs. Okay, so for this one, uh, what I want you to see is take a look at the unit circle and take a look at what happens as we graph this unit circle. I believe this looks like this is the sine. So here's the curve of the sine as it's going around the unit circle. What do you notice about this thing as it goes around the unit circle? Look at where it crosses the x-axis. Looks like it crosses at pi. Looks like it crosses at 2 pi. Look at the spot on the range where it's 1. Looks like it's pi over 2 and 3 pi over. And negative 1 is 3 pi over 2. Those are key spots. See how this is going along my unit circle? Think about if we had to ask ourselves about this sine, what would happen if I kept spinning in the circle? Like that is, what if I went beyond 2 pi? Or what if I went in the negative direction? What would happen there? See, this graph, if you look at it, this graph has what's called a period of 2 pi. Why do I say it has a period of 2 pi? It's because if I go beyond from 0 to 2 pi in either direction, this curve is going to continue on and on and on. Okay? So if you think about it, the period, so I'm showing you how this part right here, whoop, this part right, the red part is the graphic that you've seen. But if you notice, if I extend this out in both directions, it keeps going and it looks like it goes in increments of 2 pi. It looks like it goes in increments of 2 pi. So the period now is going to be 2 pi. The period is going to be 2 pi. Okay? So the period is 2 pi. What does that mean? That means that here, here, and here it repeats itself. So the domain, what would you say the domain of this function is? Am I allowed to plug anything I want in for x? Think about your unit circle. You sure are. So the domain is from negative infinity to infinity. What does this mean? This means you're used to saying all reals. Okay? But get used to seeing this notation because that means all reals as well, from negative infinity to infinity. Range is output. What is the highest and lowest value that the sine curve will ever reach? Well, that goes between negative 1 and 1. And when I do it with the brackets, that means it can be included at 1 and negative 1. It is never, ever, 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 ever going to be smaller or bigger than negative 1 or 1. Now it says function type. You have heard of even or odd. So that way you know how it works. Odd functions are symmetric with respect to the y-axis, as you can fold them and put them in your pocket. So the sine function is what we call an odd function because it has symmetry. Okay, so to kind of cover this up, what we're talking about is a period of a function is the amount of time or length of a complete cycle. So in other words, how long does it take for our graph to repeat? All right, so let's take a look at the cosine. Okay, so looking at the cosine, take a look at what's happening here. looks like the same exact thing is happening, except notice how where it starts from and where it's going. It starts at 0 comma 1 and it goes and it goes and it goes right back there. So I guess my question is, what do you notice where it starts, where it's 1 and where it's -1 for the output value? Do you notice where it crosses the x-axis? And what would you say this guy's period is going to be? So here's the graph. If you notice, this is the cosine curve. So is this. This is the cosine curve as well. So the period of this is 2 pi. What about the domain? Well, the domain, it goes from -infinity to infinity. The range, the highest it goes is -1, or lowest it goes is -1, and the highest it goes is +1. And so cosine cosine is what we call even. Cosine is an even, where it has rotational symmetry and not reflection symmetry. In other words, you can see, actually this is actually drawn wrong. The cosine of x is supposed to, no, that's right, we're good. So state all values for which sine of t is equal to 1. If you think about the curve of the sine of x, if you plug it in your calculator, it goes like this and it goes like that. So where is it 1? If that's 1, this is y equals 1. Where is the sine equal to 1? Well, the sine is equal to 1. If you think about where is the sine? Do you remember this thing right here? Remember this? This ditty right there? What's that number? Oh yeah, that's pi over 2. So we're going to say that it's equal to, x or t. T is equal to pi over 2, but that's not everywhere. That's just right here. But what about if it goes right here? How far is it from here to here? Well, that's 2 pi. What about right here where it's also 1? That's also 2 pi. What if I keep it going? Well, then that's also 2 pi. So to make that happen, I have to write plus or minus 2k pi. Where is k? K is any integer. If I do 1, if k is 1, so that's right here. That's right here. If k is 2, it's 4 pi, so it's over here. If it's -1, it's right here. Does that make sense? Hopefully. What about where the cosine is equal to -1/2? What about where the cosine is equal to a -1/2? Well, here if you think about your curve of cosine, cosine starts at 1, 0, and goes like this. But it keeps going, and it goes like this. So -1/2 is like right here. So if you take the first part from here to here, which is the 2 pi, it hits a half here and it hits a half here. And if you think about your units, -1/2. If you think about your unit circle, it's if you look at your unit circle, it's at 2 pi over 3, and it's also at 4 pi over 3. And that's because of that right there, these two guys right here. But this guy jumps to right here, that's a difference of 2 pi. This guy jumps to right here, that's a difference of 2 pi. So to make that happen, I gotta go plus or minus 2k pi. This is gotta be plus or minus 2k pi, if that makes sense. All right, we've talked about sine, we talked about cosine. Let's talk about tangent. Okay, so tangent. If you look at tangent, what do you notice about tangent? What do you notice about tangent? You can see here that tangent has this is goofy, and it's almost like right down here is goofy, and right down here is goofy. It looks like you have asymptotes in certain spots. So realistically, where does the sign repeat itself? Where does the sign, like what's the period of the sign? Like this part right here is what I'm dealing with, because then it repeats itself here and it repeats itself here. So if I go from negative pi to pi, pi over 2, this is pi over 2 distance from here to here, and from here to here is a pi over 2 distance. That creates a grand total of a period of pi. And you have, why are there asymptotes at negative pi over 2, pi over 2, 3 pi over 2 is my question. Why does that happen? Well, that's happened because remember in our table where it says it's undefined at those locations? Well, it's undefined at all increments of pi. So if you go back right here and you take a look, what's the period of our tangent function? Well, the period of our tangent function is pi. Okay? The domain is all reals, so you can write all reals except odd multiples of pi over 2. In other words, at pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, negative 3 pi over 2, all of those pi over 2s, these spots right here, these are all asymptotes. And they're all odd multiples of pi over 2. Now, what's our range? Are we allowed to have anything we want? I think so. Our range is all real, so I'm going to write it like that. Now, if you had to tell yourself, is this an even or is this an odd? Is this an even or is this an odd? Do we have symmetry? Can I fold it up and put it in my pocket? Is that what it is? Or is it odd where you have rotation symmetry? And I believe it's odd. This says odd. This is an odd function. So state all values for where the tangent is equal to 1. Well, if you think about it, your tangent curve looks like this. There's your tangent curve. And so y equals 1 right there. So where is, or if you want to look at your unit circle, where is the tangent equal to 1? And according to you, it says t is equal to, I think, pi over 4 is where that's at. But is that the only spot? Because where's the next spot it's equal to 1? The next spot would be further on down the line. How far is it from here to here? What's that distance from there to there? I believe that's pi, right? So I'm going to write plus or minus k pi because that's the next period that we go through. So hopefully that makes sense. Please, I pray that you took good notes. I look forward to seeing you in class later on, and may the force be with you.